Okay, class, today we're in section 13.3, volume of spheres. Section 13.3, volume of spheres. Write down the section number and the title. Get it in your notes right away. Okay, today we're going to learn how to find the volume of a sphere using a formula. How to find the volume of a sphere using a formula. The volume of a sphere. The volume V of a sphere is 4/3 pi times the cubed of the radius. The volume V of a sphere is 4/3 pi times the cubed of the radius. So volume is equal to 4/3 times pi r to the third power. Volume is equal to 4/3 pi times r, the radius, to the third power. Okay, make sure this is in your notes. Volume is equal to 4/3 pi times r to the third power. That's the radius. Now let's take a look at this diagram right here. And you see how it makes a circle? Even though it's a sphere because it's three-dimensional, but it makes a circle. All right, now, when you go halfway across a circle, that is called the radius. All the way across the circle is the diameter. Halfway across the circle is the radius. All the way across the circle is the diameter. So if I were to tell you that the radius was equal to 5, from here to here was 5, that means that the diameter would have to equal to 10. Once again, if I said that the radius was 5, that means that the diameter has to be 10, the total distance across. And the inverse of that is, if I told you that the diameter was 10, that means that the radius has to be 5. That's halfway. Another way of saying it is that the diameter is equal to 2 times the radius. The diameter is equal to twice the radius. Or you can say the radius is equal to 1/2 the diameter. The radius is equal to 1/2 the diameter. All right, please get that in your notes. Okay, let's make sure we understand example 1. Find the volume of each sphere. Round your answer to the nearest tenth if necessary. Use 3.14 for pi. So here we have our diagram, we have our sphere, and they give us a radius of 2.1. First thing we do is we write down the formula. Volume is equal to 4/3 pi times r to the third power, also known as r cubed. I bring my 4/3 down because it's in the formula. They told us that pi was equal to 3.14. And we found that the radius was 2.1. So I have 4/3 times 3.14 times 2.1 to the third power. The first thing I figure out is 2.1 to the third power. That means I'm saying 2.1 times 2.1 times 2.1. That's going to give me 9.26. So now I have 4/3 times 3.14 times 9.26. So what I would do now is I would say 4 times 3.14 times 9.26 and then divide it by 3. So my last step is to divide by 3. Once again, 4 times 3.14 times 9.26, I get that answer, and then I divide by 3. All right, so you can see that out. It's 4 times 3.14 times 9.26 divided by 3. 4 times 3.14 times 9.26 divided by 3. Well, 4 times 3.14 times 9.26 is equal to 116.30. Now, divide that by 3. And when you divide that by 3, you should come out with 38.8. And then round off if you need to. Right now they say round off to the 10th, so that's what you're going to get. All right? Now, if you're still confused on the 2.1 to the third power, all that means is 2.1 times 2.1 times 2.1. Put that in your calculator or multiply it out by hand, and you end up with 9.26. Now in example B, we still have to find the volume, but in this case you'll notice here they give us the diameter, the total distance across. So that means the radius only goes from here to here. Now since the diameter is 7, that means the radius is going to be half of 7. So in other words, the radius is going to be 7 divided by 2. And 7 divided by 2 is equal to 3.5. So now let's look at our formula. Volume equals 4/3 times pi times r to the third power. 4/3 times, what's the value of pi? 3.14. What did we determine the radius to be? 3.5. Why was that? It's half of the radius. So it's 3.5 to the third power. And then we do the same thing we did up in part A. We're going to say 4 times 3.14 times 42.9 and then divide that by 3. And that's going to give us 179.6. 4 times 3.14 times 42.9 and then divide that by 3. And that's going to give us 179.6. All right, once again, so it should be 4 times 3.14 times 42.9. Now, where did that 42.9 come from? 3.5 times 3.5 times 3.5 is equal to 42.9. So I multiply everything going across, and then I divide by 3. And I'll end up with 179.6. So the volume is about 179.6 cubic centimeters. Okay, find the volume of a sphere in a real-world context. Find the volume of a sphere in a real-world context. Many sports, including golf and tennis, use a ball that is spherical in shape. Example 2. Soccer balls come in several different shapes and sizes. One soccer ball has a diameter of 22 centimeters. What is the volume of this soccer ball? Round your answer to the nearest tenth. Use 3.14 for pi. Step 1. Find the radius. Radius is equal to the diameter divided by 2. So that's going to be 11. So radius is equal to the diameter divided by 2. That's going to be 11. Now what was the diameter? They told us it was 22 centimeters. So 22 divided by 2 is equal to 11. Step 2. Find the volume of the soccer ball. Volume is equal to 4/3 times pi times r to the third power. 4/3, we bring it down because it's in our formula. Pi, once again, they told us was 3.14, and the radius we figured out up here was 11. So now I got 4/3 times 3.14, and what is 11 to the third power? That's 1,331. Once again, 11 to the third power means 11 times 11 times 11. 1,331. Now I multiply everything going across the top. 4 times 3.14 times 1,331 divided by 3. 4 times 3.14 times 1,331 divided by 3. After doing that, my final answer would be 5,572.4533. They told me to round to the nearest tenth, so by doing that, I would end up with the volume being about 5,572.5. Now, why is that? Because the tenth is located right here at that 4. The 5 is greater than or equal to 5, so therefore the 4 would become a 5. So once again, 5,572.5 is my final answer.
You know, when they say take me out to the ball game, they don't actually specify which ball game. Of course, you normally think about it being, baseball, but it actually could be basketball. There are lots of different ball games. And in fact, all the games that we think about, well, I guess except for football, actually involve spheres. So let's take a look at a question that involves the basketball and the baseball. Let's check it out together. So a basketball is a sphere with a diameter of 9.5 inches. And a baseball is a sphere with a diameter of 4 inches. The question for us to think about is how many times greater is the volume of a basketball than the volume of a baseball? So that's the question. I want us to think about it. So let's try to think about it. Well, we know information about the diameter, which will allow us to compute volumes. So first, let's find the volume of the basketball. Then let's find the volume of the baseball, and then compare the two volumes. All right, so here we go. So the volume of the basketball. Well, let's see. I know it's going to be 4/3 pi r cubed. Well, I don't know r. I'm given the diameter as 9.5. So we know the radius will be half of that. So that's going to be 9.5 divided by 2 all cubed. Now, what does that work out to be? Well, if you estimate that in a calculator, you get approximately 449, and we have inches cubed. Okay, now what about the volume of a baseball? Well, that's going to be 4/3 pi times. Well, now, again, we're not given the radius. We're given the diameter is 4, which means this radius will be 2, and 2 cubed is actually going to be 8. So, well, I'll write 2 cubed so you can see, but that actually is 8. And we can estimate this on a calculator to be about 33.5 inches cubed. And we want to know how many times greater is the volume of the basketball than the volume of the baseball. So we divide and take 449 divided by 33.5. And if you work this out in the calculator, you see approximately 13.4 times. What does that mean? It means that 449, that volume, is approximately 13.4 times the volume of the baseball. So you can see that we can actually gain insights into objects that we throw around all the time, and we can do that by throwing around some great ideas in mathematics. Here, you catch this one. Ready? Woo! Did you get it? Did you miss? How about this one? You want to catch this one? Here we go. Catch this one. Here we go. Wow. Well, good shot. Hope you caught it. Anyway, have fun.
Okay, that concludes our lesson. Let's get started with today's assignment.